Good morning, students. Due to us not being able to get on campus, I am recording this so that we can still cover the rest of the math chapter. Now, this chapter is important just because it is the base for a lot of things that we're doing. So make sure to study this one. Make sure to memorize this chart as we will be using it quite often, and this information will not be given during the exam, so you'll have to have it in your head. Okay, so put a star next to this one and start working on it. Make sure that you know how to convert from one to the other, which at the beginning, it's going to be pretty challenging to be able to convert from one to the other. So get some practice in. I really like watching like YouTube videos, pausing it before they, or so I'll start the problem, try it by myself, and then watch the video. That way you can see if you understand it, but also see how somebody else does it. Okay, so make sure to memorize this chart as soon as possible. Now, let's do a little bit of converting practice. So here's some problems that I have on here so that we can practice converting from one unit to another. So the first thing that you're going to notice on here is is that on here I have like the milligrams to the grams. So make sure to know these acronyms. So the mg stands for milligrams, and then the g by itself is just grams. Another one, we have that kilogram. And if you notice, it does go with the chart. So kilogram, kilogram, right there. Now, okay, so just make sure to know where on the chart it is, know the prefixes, what letters correspond with each of them. So like pico, over here, we're not going to use MC, we're only going to use this value. So make sure to memorize that one instead. And just recognize what uh, what the prefix means. Now for the base unit, there's going to be the grams, liters, and meters. Okay, so those are going to be the different base units we have. So grams, liters, and meters. Okay, great. So now let's go through these problems. I'm going to have a little more space down here so I can work through them. So from milligrams to grams, I look on my chart, I see that I have this 1 times 10 to the negative 3. So that value is always going to go with grams. Okay, so when I try to make my conversion factor for this one, I'm going to do milligrams over grams. And let's see if that works. If not, we'll change it. Okay, and then we put that number with the grams, so times 10 to the negative 3. Okay, and then we know we are going to convert from 10 milligrams. Okay, and we're trying to get to grams. So we look at our units, and we can see we have milligrams on top, we have grams on bottom. Those will not cancel out. Thus, this conversion factor isn't quite going to work. So what we have to do instead is we flip it. So mg, we want the mg on bottom, okay? The milligrams on bottom. That way it can cancel out with each other. And on top, we want whatever we want to end with, 3 grams, okay? Because this is here, they're going to cancel out, and our final unit is going to be this, okay? And then we just times out those values, so we know the 10 times 10 to the negative 3 is going to equal 0.0. Okay, and if you're not sure, always put it in your calculator, or you can move your decimal points point by point, okay, whichever way works best for you. And then last thing, which is very important, and I forgot, is going to be to put the grams at the end. Okay, always add your units. It'll help you to be able to double check your problem and know if you're missing anything, okay? So make sure to do that. Okay, next problem we have is going to be meter to micrometer. Okay, so on here, We can see that micro is right here, micrometer. So we know that I have 1 over micrometer. Okay, and so because we have it that way, oops, let's give myself a little more space. Oops. Okay, and so with the meters, we put that 1 times 10 to the negative 6. Okay, so we're going to put, sorry, I accidentally backed out of it. Okay, there we go. That'll fix it. Okay, so whatever value is here is going to go with whatever the base unit is. So here the base unit is meters, so that's why we put that there. Now we are going to times it by the 1201 meters. Okay, and again, we're going to double check, make sure that our units cancel out. Here I have meters, here I have micrometers, so those are not going to cancel out. So just like the last one, I'm going to need to flip that conversion factor. So meters, okay. And I flip it because I want the meters to cancel out. So I want the meters on, if I have it on top, I want it on bottom so that those can cancel out. And then I put y1 times 10 to the negative 10 on the bottom, and then micrometer on top. And I'm going to put a 1 on it just because it makes me feel better. Okay. So this one's going to be a little bit harder to do in my head. So I'm going to double check my answers. Okay, cool. So this one is going to be 1, 2, 3, 4. Okay, and then we actually add 6 zeros to it. 1, 2, 3, 4, 5, 6. Okay, so comma, comma, comma. So that's going to be our total number. If we want to put it into scientific notation, we put 1.201. Okay, because remember we want one whole number in front, and then we put any of the following values behind it, and then times 10, and then this one is going to be times 10 to the 9. And I know because I have 3 commas, so that means I have 9 extra um, extra decimal points. Okay, so that's going to be our answer for that one. Now let's do the one that's a little bit trickier. So I'm going to jump to this one here. Okay, so the tricky part about this one is so far we've just been converting from the base unit to something or something to the base unit, which is a little bit easier to do. But on this one, we're going from milligrams to kilograms. So for now, what I would suggest is to convert first to the base unit and then convert to the second unit. Okay, so milligram, I know how to convert from milligram to grams. And so 1 milligram over grams is going to be, sorry, 1 times 10 to the negative 3 grams. Okay. However, just like everything else, we're going to put it 10 milligrams. Okay. And we can see again, we have it upside down. So we need to fix this. We know it doesn't quite work because we have grams here, we have milligrams here. They're not going to cancel out. So we just flip this around. Oops. Put the 1 milligrams on bottom, but 1 times 10 to the, let's double check it. Milligrams, yep, got it. Okay. 1 times 10 to the third grams. Okay. So we're in grams now. So we just put in our answer. So it's going to be 0.01 grams. But now we're not quite done because we still need to get to kilograms. So for kilograms, this one is going to be, it's going to be 1,000 grams makes 1 kilogram. Okay, as we can see, I have grams on top, I have grams on bottom. Now they can cancel out. And then we just times it through. On this one, we're actually going to divide it. So it's going to be 0.01 0, see, 1, 2, 3, 1 kilograms. Okay. Then if we want to put in scientific notation, I would put 1.0 times 10 to the negative 5 kilograms. Okay. So that's going to be how we do our unit conversion. Okay. Just look at your factors, make sure that you're canceling out the correct units, and then times it out. Okay. Always double check on if your units cancel. That way you can see if you did it correctly or not. It's a really good way to double check. A lot of problems you can get away with just looking at the units and solving the problem that way. Okay. But definitely practice this unit conversion. It can be uh, challenging at the beginning, but once you do some practice, it does get much easier. So make sure to get that practice in, okay? Okay, and then here's the answers for if you want to double check your problem or your work. Okay. Now, the next topic is going to be sig figs. So I'm not going to cover this one too thoroughly, just because this one will not be tested on. This one you'll use a little bit in lab, so we're going to go over it, okay? So on this one, um, the point of sig fig is so that we can tell how accurate and precise our measurements are. Okay, so if I say something is 1 meter long, and I don't tell you any decimals or I don't tell you much more information, tells you how accurate that is. All you know is it's about 1 meter. Okay, but if I told you this is 1.00 meters, then that's a lot more accurate. That'll tell you that this is a lot closer to exactly 1 meter. Okay, so we've made this significant figures to be able to know when to round and how accurate we can say an answer is. Okay, so for example, over here we have this meniscus. If you guys are in lab, you've probably looked at this already. But if you look at the bottom of this, it's a little bit hard to tell exactly where it is. I know it's above the 4 line. Okay, we're good on that. And then if I count up, it's 1, 2, 3, 4, 5. So it's above 4.5. But in between those two, it's a little hard to measure. So I can maybe say this is 4.5 with 100% surety that that's correct. However, I would probably guesstimate this is about 1.5, let's say 7. Okay. And so this last number is not very accurate. These two are accurate. Last number is a bit of a guesstimation or an estimation. So that's why we do need to make rules of when something is accurate and when something is not. Okay. So when we're looking at these, one thing is that there are numbers that are exact. And so I know for a fact, no matter how many decimals it is correct. For example, if there are 12 eggs in a dozen, so a lot of the conversion factors are going to be exact numbers. Okay, they don't have any significant figures. Whereas when we measure something, that one is not exact. We can measure it to a certain digit, but some values are going to be a little uncertain. For example, on this 5. Okay, so there are rules about how to measure if a sig fig is accurate or not. So there's rules for when you do addition and subtraction and rules for when you do multiplication. And so we're going to go through both of them real quick. Okay, so when you're adding or subtracting, what you're going to do is you're going to look at how many numbers you have for each of them. And most importantly, you're actually going to look at how many values there are after the decimal point. So this one, we can see I have 3 numbers after the decimal point. But over here, I only have 2. So because of that, I can say on this one, I'm a bit more accurate, but on this one, I'm not. So because of that, I'm going to go with whatever my least accurate is after the decimal point. So for this one, I have one that's only 2 spots after the decimal, so my final answer is only going to have 2 spots after the decimal. Okay, and then anything after that is going to be rounded. And as we can see, we rounded from 7 to 8. Okay, so that's how we're going to do addition and subtraction. Look at the decimals and then see which one has the least amount of decimals, and that's going to be how many decimals you should have in the end. Okay, and I think I forgot to do one for multiplication, but no worries. Okay, so let's go on to accuracy and precision. So these are going to be two concepts that seem similar but are very different. So accuracy is the degree to which a certain measured result agrees with reality. Okay, so how correct are your results? Okay, and then precision, on the other hand, is to which measure results are repeatable. Okay, so if I run an experiment 100 times, how many times am I going to get the same answer? Now, precision doesn't quite mean that it's accurate, and accurate doesn't always mean it's precise. So down below, we do have these examples of targets. Okay, so the first one is accurate and precise. We can see that it's on the bullseye, so that's going to be accurate. It's also very precise because all 5 of our or 6 of our shots are going to be in the middle. So accurate and precise. Now over here, I have not accurate. So the shots are nowhere near the bullseye. So they're not accurate, but they are precise because we can see that they're all repeatable. They're all very close to each other. Now on this one, I have this is accurate. And you can tell this is accurate because they're all close to the bullseye. And if you took the average of them, it would probably be somewhere in the bullseye. However, it's not very precise because I can't circle a small area and find them all in one spot. They're all a little bit spread out. So they're not going to be very precise. And then this last one is not accurate and not precise. As you can tell, all of them are in different spots. None of them are that close to the bullseye. So that one's going to be not accurate and not precise. Now, the last thing that we need to learn on the math section is going to be dimensional analysis. So dimensional analysis is a way to be able to do longer math problems, and it really helps to be able to keep track of our units. Okay, the units are going to be really important just because, again, I said you can double check your answers and be able to see if we got things right, if we have the correct units. It's very helpful to double check. Sometimes I'll forget things, sometimes I'll flip my equation upside down. So having the units to double check is very helpful. So I highly recommend to be able to do dimensional analysis. It's not required. You can do it step by step instead, if that makes more sense. But dimensional analysis will be helpful and may also be helpful in other courses if you learn how to do it now. Okay, so dimensional analysis. Let's do a problem with using dimensional analysis. So on this one, I have what is the mass of a 49.6 milliliter sample of a liquid, which has a density of 0.85 grams over 1 ml. Okay, so on this one, okay, so I'm going to write down my 49.6 mLs. Okay, so, and then I want to find the mass. Okay, mass. And then if I remember back on my SI units, mass is typically measured in grams. Okay, so just keep that in mind. So if I want to get to grams, I have grams here, and I have mLs here, which looks like it might work out. So I'm going to put times, and like I said before, we want to cancel out this unit, so make sure to put that unit on the bottom. So I'm going to put ml down here. Okay, and then that means that I'm going to have grams on top, which is 0.85. Okay, so that works out really well because now my milliliters are going to cancel out, and I'm just going to stay with grams. And let me hurry and put in my calculator. Okay, now if I put that into my calculator, it gives me 42.16. Okay, and this is in grams. Okay, so this is going to be my dimensional analysis. Now let's try another one. Okay, this one's going to be a little bit trickier, a little bit more involved. So on here, I have it. Well, the question is, an iron sample has a mass of 4.50 pounds. What is the mass of this sample in grams? Okay, so I have the pounds, I have the mass in pounds, but I want it in grams. Okay, I see I can have grams here. So, but that's in kilograms. So I'm going to have to go through all of these to be able to get to grams. So first thing first, I'm going to write down my 4.55 pounds. Okay. And then times, I know I want pounds on bottom so that I can cancel that out, right? I want to get rid of those pounds so I can have units of grams. But on this one, I have the kilograms on top. And for the conversion, I'm going to have that 2.2046 on bottom, and then I'm going to put a 1 on top. You don't have to, but I like it. Okay, so now I'm in grams. Oh, sorry, I'm in kilograms. There we go. Okay, but I want to get to grams. So again, I have kilograms on top. I know I want to get rid of them, so I'm going to put it on bottom now. And I know that 1 kilogram is equal to 1,000 grams. So I can put 1,000 grams on top. Okay, so now if I want to double check my units, I can see my pounds cancel out because I have 1 on top, 1 on bottom. My kilograms cancel out because I have 1 on top and 1 on bottom. So my only unit left is going to be that 1,000 grams. So now I can just put that into my calculator. Okay, and it gives me about 2,041.2. And this is in grams. Okay, so that's going to be our final answer. So that's how we're going to use dimensional analysis. We just write it this way, and we write it in a line so that we can see all the units, we can see what timesing out, and that way we can keep track of everything. Again, you can work it out in steps, break it up, if that makes more sense to you. Either way works. Just practice it, make sure that you can do those conversions. Okay, and that is the end of our math section. Okay, let me know if you have any questions. Let me know if you would like more practice on math, and I hope to see you guys next week in class.